going to talk about protective coatings in cartridges, specifically for the pipeline industry today. And I'm going to guide you through the agenda first. We are going to take a look at the challenge that we are seeing in the field, which is coatings are being manually mixed and applied. Then we are going to take a look at the solution that we provide. And we are going to go through the systems, also take a look at the application areas. Then we are going to do a head-to-head comparison, cartridge versus manual mixing. We're going to take a look at the benefits. We are going to also take a look at two case studies that have been done a couple of years ago in the US and in South Africa. And then we are going to summarize, and in the end, we're also going to have two questions which we would like you to answer. So I'm going to start with a challenge. We have a couple of pictures of a current application, how it's being done in the field. So the challenge is, how do we mix two component coatings in the field without contamination of the product? We need to handle component A and B, which are in separate buckets or tins. Then they are going to be mixed in the field. There is a risk of parts of the component A and B staying as residual waste in the tins and buckets that are being used. So here there's also a risk of an uneven division of ratios. Also, in the manual mixing process, there's a risk of not stirring the materials properly. Also, the major topic is that everything that is being done manually, and you don't have a consistency from applicator 1 to applicator 2. So one applicator decides to mix the product properly, which is going to take him 2 or 3 minutes, and the other one decides to do it 30 seconds, and in the end, we find it to be not good enough for the material to be performing as it should. And this is exactly where manual application and also manual preparation has its limits. Also, and this is a topic that we've been addressing with cartridges in the adhesive field, is waste of materials. The standard kits that are being used in the field right now, component A or component B is poured into the other component and is then mixed in full. The suppliers or the coating suppliers do that because they don't want the personnel in the field to measure out or weigh out the components. So they create kits that are mixed in full and then applied in full. And here the risk, or let's say the waste that is happening, is if you don't need the full amount that is being pre-mixed, it's going to cure, no matter if you apply it or not. And this is always, in every application, a bit of waste that we can avoid by using a cartridge, because in a cartridge you can reclose the cartridge and use the rest of the cartridge for the next application. And this is a crucial fact in manual application being compared to a cartridge application. Also, specifically when you look at the handling of component A and B, most of the times the components being unmixed are a risk to the health of the applicator. And if you are using a cartridge in combination with a static mixer, you don't have access to unmixed component A and B. So you avoid the direct contact of skin, eyes, or even gloves before the components are being thoroughly mixed. Also, a very strong argument for using cartridges is the preparation time to prepare the application. Because if you premix, you have to set everything up, you have to do the manual application, and this is exactly where you are losing time and where there's a risk of failure. Sorry, 1 second. Sorry, there was just the light was going off and there was sounds in the room. Sorry for the interruption. So we face the challenge right now, and now we are going to the cartridge-based two-component application systems that we provide. The first thing I would like to do is I would like to show you what the main applications in the pipeline industry are right now. So we've seen that weld joints are the number one application in the pipeline industry. Why is a weld joint such a predominant or such a good application for our system? That's pretty easy to explain, because a weld joint is a limited space, so you don't need liters and liters or kilos of coatings. It's a small application, and it is every 11, 18, depending on the length of the pipe, it's a repetitive application. So you have all the benchmarks for our system to perform perfectly well. First of all, it's a small application, so setting up an airless device does not make too much sense. Second, it's a repetitive action that needs to be done on every single weld joint. You can measure out how much paint is used for every joint. You can place the cartridges needed for the joint on the joint, access it only with a small vehicle with a compressor on it, spray the coating, and then go to the next joint. So here it is a perfect match for the system that we've generated. The second is repairs, damages, and pinholes. So when you've done holiday testing or any type of testing and you found damaged spots in the coating, they need to be repaired. And this is sometimes a hassle, because you don't need a lot of paint. You need a small amount of paint. And very specifically for these small applications, we are using our smaller systems, which in this case is a 50 milliliter cartridge and a DMA tool, to be able to apply a very small amount and have a very small residual waste, as the static mixer is significantly smaller as the bigger spray mixers. The third is here we are talking bigger areas. We are talking about fittings. We are talking about valves that are being put into the line. There's going to be repairs on these parts. There's going to be any type of fittings. And here the work a lot of times is done where you don't have access to a paint room, or you don't have access to a paint reactor. And here the system gives you the advantage that you are able to spray in every type of location that has enough ventilation and protection for the applicator. So this means you are literally able to spray wherever the part is welded or put together before installed into the pipe or welded into the pipe. And this is it gives you a very good freedom of acting. So you can build or repair your part wherever you want to and spray it with a mobile device that gives you the freedom of acting. And these are the main areas that we are going to focus on in this presentation. Now, a short introduction, like a theoretical introduction into how our systems work. It is very, very well known in the world of adhesives, and I've seen a lot of people that are actually very, very well trained in adhesive on these kind of systems. In the coatings, it's not that well known. It's not a standard application system. So literally what you do is you prepare your cartridge. In some cases, you need to shake it up. In some cases, you need to heat it, specifically in the pipeline business, as we are talking thick film coatings. And then you attach the mixer. You put the cartridge and the mixer into the dispenser. You need to purge the mixer to assure that the mixer is uniform, and then you can start spraying. After spraying, cartridge and mixer are contaminated with coatings. There's a little residual coating in the cartridge. This is going to be disposed. The main advantage of disposing this is you don't have the effort of cleaning anything. So literally, after you are finished, you take the cartridge out of the dispenser, put it into the waste, and you are done. And this is also a very big advantage because you don't need to clean any tools that are being used throughout the process of mixing or application. Now we're shortly looking at the main tools that we supply into the business, which is on the left-hand side, the spray dispenser. This is a handheld dispenser that holds all the ratios of cartridges available. It is like a standard spray gun. It has a dual stage trigger. So if you pull the trigger in half, the atomization air will be activated. And if you pull the trigger full, the material flow starts. And this is a standard in the spraying in the industry. This is why we've copied it to give the applicator the feeling that he knows how the tool is operating. Also, what is a great advantage is that you are handling the full device. You don't have a bigger unit that you need to transport to the location. You have your air hose. Obviously, you have the compressor, which is a slightly bigger, but you have everything you need in your hand to spray. And this is very interesting. For the pipeline, a lot of times you have to spray on top or below the pipe. For this specifically, we have mixers with 90-degree angles. Some customers really like these mixers for the top and the bottom of the pipeline. Some spray it with a straight one. I just wanted to point out the availability. Secondly, we have the MixCoat Flex, which is a unit that is used in workshops and is more difficult to transport, but you have a hose of 1.50 meters or 3 meters, and you can walk around the stationary tool with a handheld device that is actually like an airspray, like an airbrush. So it's small and easy to use. So these are the main application tools for the cartridges if sprayed. Now we are going into the comparison. I made a small AI image on a cartridge and mixing in the field. So obviously you can see you have a very clean environment. You put the cartridge into the gun, you dispense, and you only have contact to ready mixed paint. And this is a crucial advantage. You don't need to mix. You don't need to worry about mixing ratio or mixing quality. If the system is properly tested with the cartridges, it will work each and every time. The static mixer is one of the most reliable technical tools. So here, normally you don't find any difficulties in the use. Coming to the actual process, first of all, the mixing ratio. So if you pour one component into the other, it's always a manual process and there is a risk of failure. The mixing ratio is precise with the cartridge and the static mixer every time. Setup time. So it's very easy to understand. You either put a cartridge into a dispenser, and on the other hand, you need to open a tin. You have to pre-mix the tin. The second one, pour the one into another. So we don't even have to think what is the quicker and better solution. If you take a look at waste of materials, we've had that once already. Everything that is left over when pre-mixed is waste. And with a cartridge system, we mix at the point of application or the point of use. So there's a minimal waste, and this is the residual material inside of the mixer itself. Film thicknesses. If you manually premix, you brush and roll the material on, it is much more difficult to achieve a consistent layer thickness when rolling or brushing. It is very uniform if you have a spray application. So here also the advantage is clearly on the cartridge side. Worker safety, had that point also already. We don't want to be in contact with any type of solvents for cleaning. We don't want to be in contact with unmixed material. Cartridge system is a closed system. It is low pressure. So even when comparing it to an airless unit, you don't have any piercing of skin. It's a low pressure system with a very, very effective application rate. Training. It's a challenge if you want to properly mix material in the field by hand. To use a cartridge, you need instruction, of course. You always need instruction if you would want to use something properly, but it is a very short instruction that is needed, and a cartridge is very easy to use. On the equipment cost side, we are a bit more expensive with a cartridge system as you need the dispenser, but the dispenser is a tool that is used repetitively. So you don't throw it away. It's a one-time invest. And the only additional cost that you generate is the filling and the cartridge themselves. Let's take a look at the reliability of the system. It's also very well known from the adhesive business and pretty much new in the coating business. A cartridge guarantees a correct mixing ratio with every single application, and the static mixer eliminates the manual dosing and mixing errors. And as already said, spraying is one of the most reliable way of generating a solid and consistent wet film thickness. Sorry, here's a dry film thickness. Sorry, that is wrong in the presentation. So we produce reproducible results, and the coating quality matches the factory coating of a standard pipeline. So as you can see in the picture on the right-hand side, that was a movie that we've done in Spain. And here the target was to use the same coating on the weld joint as on the pipeline. And this is exactly what we've done. So here we found a very high interest of even the pipe manufacturer to use the same coating because they didn't want any complaints on insufficient corrosion protection. Looking at costs. Here, the cost saving, we have to be pretty clear. These informations that I'm showing here are based on a case study done in South Africa. So all labor costs and affiliated costs are based on loan and salary in South Africa, which is a low income country. So these percentages can shift significantly in other areas. So we took a look at the reduction in labor hours that is not linked to cost. We saved 50% in this specific application. That was weld joints on a water pipeline for Rand Waterworks in Johannesburg. The cost savings per joint, although labor cost is fairly low, was 15 to 20%. Comparison here was to a wrap that was performed before using the liquid coatings, and material waste was literally none. So we go to health and safety right now. Also, a very important topic in this market. We don't have any contact to skin. That's the third time I mention it because it's very important. We don't need any solvents, no volatile organic compounds at all if the coating doesn't have any VOC inside. We use low pressure, so low risk of injuries by injection. And as the equipment is lightweight and fast, and we can finish the application fast, we reduce fatigue of the applicator. Environmental benefits, besides the picture on the right-hand side, was sprayed with our system in the course of the South African project. So this was the quality that we achieved on site using our system. Just to give you a visual idea on the quality we've achieved on site. We've seen that we have lower overspray rate compared to high pressure applications or spray reactors. No solvents were used for cleaning, and the empty cartridges hold very little material, and it's very little hazardous waste that we need to dispose or even pay for disposal. And the only required, so the material that is required for the joint is mixed, and we don't have any material that is already pre-mixed that is wasted because of the fact that it's curing after we've applied the material to the joint. And what was a big topic in South Africa, we have a reduced contamination risk of the soil, of the water, of everything that surrounds the point of application. In this case study, we also took a look at the processes and compared the two. So here, this is a very, very easy comparison. The presentation will be available afterwards. I really want to focus on the effective time for the application, and we are talking 3 to 5 versus 40 to 85 minutes here. And this is per application of one cartridge. So this might be a little bit longer when you need more than one cartridge for a joint. We've been talking about the case studies a bit, so we are going to take a look into these a little bit. Although we are already a bit late, we have to speed up. We had one case study done in Arkansas and Texas with Denso, USA, and we had a case study done with Stonecore in Johannesburg, South Africa. Materials are in the presentation. And I just give you a glance on what we've done. So in the US, we had, as I said, parts being coated in the warehouse, not in the warehouses, in the workshops and on site. We also had weld joints being coated. And the key factor for Denso at the time was the uniform wet film thickness they apply on site, and with that, the uniform dry film thickness that they've achieved when the joint or the part was ready for installation. And that is also something that we get from literally every company that uses the equipment. No cleaning, less equipment, less waste. We are fast and mobile. And this is a key factor if you want to move from joint to joint, or if you're in a small workshop and you just need to coat a fitting that needs to be installed. On the South African project, that was a pipeline, as I said, that's been wrapped before. Here, I'm not going to go dive into comparing a wrap or a liquid coating. I will highlight that air entrapment is unavoidable in this environment, and the environment includes the applicators on this specific site. So I'm not a fan of either. I like wraps, I like liquid coating, so I don't want to say the one is better than the other. In the end, in this specific case, they took out 15 to 20% of the coating per joint. And the thing that was really interesting is what Dave Thompson said after we finished the project. And that was really a first where we achieved the same or better coating quality in the field as the pipelines that came from the factory. And I think, personally, I was present and at the test. We did a better surface preparation in the field because we wanted to be very good, and that was the reason. But I agree, we did a very good job there, and the material worked really fine. So here you can see that even the paint manufacturers were very happy with the results that we've achieved in the field. Small summary. We are reliable. We mix and dose correct every time. That's the key message. We are cost effective, 50% less labor, 15 to 20% cost saving per joint based on a fairly low wage. And we are safe. We have a closed system. We don't have the risk of piercing of skins. We don't use any solvents to clean. We are portable, lightweight, compact. The only energy we need is compressed air. And it works everywhere where you can operate a compressor. We're eco-friendly, no solvent. Again, we have minimal waste, and no overspray is not a lie, but it's not that true. But we have very little overspray with the system. And this is the key message in the end. One thing we need to make sure that the coating works with our system. And this is why we would like to offer you to send us your material to find out whether it works with our cartridge system. We can do testing for you. We can schedule a demo on site with you. We will have you filling on site. First of all, of course, we need to find out whether the mixing ratio meets our cartridge offer. And then we can start a pilot project and find out if we can save some money out there.